Okay, so quadratic transformations are what we're doing today. Remember, to transform something means we are changing it. Okay, so in order to change something, you have to start with something. So we always start with the quadratic parent function since we're dealing with quadratics. So the parent function, and you're going to need to remember this, is y equals x squared. So highlight it, put stars by it, whatever you need to do. Okay? Now, when we are dealing with this, okay, we're going to have our function. We're going to have an a C, and a D. Okay, so each letter does something a little bit different. So C is going to shift left and right. So if your C is greater than 0, your graph is going to move to the left. So it's kind of opposite of what you would think. If C is less than 0, your graph is going to move to the right. Okay. D is outside the parentheses and it moves your graph up and down. So if D is less than 0, it's going to go down. If D is greater than 0, your graph is going to go up. Okay. Now, if you throw a negative in the front and end up with a negative x squared, it's just a reflection across the x-axis. And this will make more sense when we start graphing them and looking at the graphs. Okay? When you change a, so the number outside the parentheses, you ignore the negative. That's all that these lines mean. Ignore the negative. Their absolute value, which you haven't quite learned about, but it just means ignore the negative. So if the absolute value of a is greater than 1, it's a vertical stretch, which means it's going to get skinny. We're stretching it out. If a is less than 1, it's a vertical compression. So it's going to get wider or fatter. Okay? So let's flip to the back and do some examples. So it says describe the transformations to f of x equals x squared. Okay, so I'm going to go ahead. We have f of x equals a x minus c squared plus d. All right, so basically what this is saying, anywhere I see an f of x, I replace it with an x squared. So in this first one, I have f of x. So in order to be able to put this in Desmos and see the transformation, I need to rewrite it. So I'm going to have negative. Instead of f of x, we're putting x squared and then plus 6. Okay? So we're going to go to Desmos. I would go ahead and leave this first line and put y equals x squared, the quadratic parent function. I wouldn't mess with the first line after that. So we're going to put y equals negative x squared. Okay? And then plus 6. So we know that that graph is flipped over. Okay? So that means that it is one transformation was a reflection across x. Okay, and that's what this negative did. If we look at the graph, and you're really focusing on the vertex, so this was our original vertex, we moved up 6. So we translated or slid our graph up 6, and that plus 6 is what did that. Okay, so let's go to example 2. Example 2, same thing. Find f of x, circle it. We're going to replace f of x with x squared so that we can put that into Desmos. So I'm going to go ahead, leave the first line there. So we have 4x squared minus 2. Okay, so the blue graph is skinnier than the red one. Okay, and the 4 is what did that because that was our A. So it's a vertical stretch because it was skinnier. Okay, and the blue one also moved down 2. And that is because of this minus 2 at the end. So it translated down 2. Okay. All right. Example 3. We're going to circle the f of x. So we have negative 1/2 x squared. I'm going to go to Desmos. Delete out that equation. Press the home button so I can stay on my normal zoom. So we have negative, remember to get a fraction, divide, 1 divided by 2, x squared. So this one flipped over, so it's reflected, and it's also a little bit wider or fatter. So it's reflected across x because of that negative, and then because of the 1/2, it's a vertical compression because it got a little bit fatter. Okay? All right, let's look at example 4. So here, when you circle this, you need to circle the whole thing. Okay? So we're going to rewrite this as 1/4 parentheses x minus 3, and we need to add the squared. Okay? If it helps, all you really have to do is cross out the f and put the squared. So we're going to go type that into Desmos. So we have 1/4, so 1 divided by 4, parentheses x minus 3. Oops, I forgot to get out of the fraction. Parentheses x minus 3, close that and square it. Okay, so if we look, focus on the vertex. We moved to the right 3, to the right 3, because of this 3 here. So we moved right 3, and then because of the 1/4, that second graph was fatter, so it's a vertical compression. Okay, so on this one, same thing. Mark out the f. We can put the squared and type that in to Desmos. So we have y equals parentheses x plus 4 squared, okay, minus 8. So if we look, we moved over 1, 2, 3, 4 to the left. And that's because of this plus 4. So we went left 4. And then because of the minus 8, and if you go back to Desmos, we moved down 8. Okay, let's look at the last one. So I'm going to cross out the F and I'm going to put my squared. So in Desmos, we're going to have -3 parentheses x plus 2 squared plus 9. Okay, so this one did a lot of things. So first we can see that it flipped. So it flipped because of the negative, so that's a reflection across x. Okay, if we look again, it's a little skinnier, so that's because of the 3. So skinny stretch, so vertical stretch. Okay, then this plus 2, if we look, it moved to the left 2. And then the plus 9 moved it up 9.